We're doing moss today. It's gonna be cool. That didn't save. Right. Whoopsie. Alright, let's get started then. The lovely quick little prayer. Hey, dear Lord, we bless your holy name. We thank you for this day. Thank you, Lord, for blessing us with another day to do your will. Thank you, Lord, for providing all the food that we have, the peace in our land. Even though our countries are going into destruction, we still have relatively good peace and relatively good quality of life in comparison to other countries. So we thank you for that, Lord. And we thank you for putting the food on our table. And thank you for my child. Thank you for our children. Thank you for, um, thank you for the reasonably good weather as well. We bless your holy name. And thank you for providing us all this knowledge in these times. You know, we can access to knowledge is so easy on the internet. You know, AI has made it a bit more difficult, but these days we want to find out if something's true, we can just search on the internet and find out the answer pretty well. So thank you for that, Lord. Um, but yeah, I pray for every one of my viewers, Lord. You help them come to the truth, the way, the truth, the life, which is Jesus Christ. Help them realize the times that we're in. Help them realize that we're just sowing the seeds for our destruction. Help them realize that the sin that we emit every day is causing all of this. Help them see the devil and the plans that he has over their lives. Help them see the devil and the plans that he has for everyone else's life. Help them realize that heaven and hell is real and that God is real, and wake them up before it's too late, Lord God. And thank you, Lord. We bless your holy name. In Jesus' name we pray. Amen. Right. Amazing. Awesome. Good to hear. Thank you, sir. I received the blessings. I received them in full. Thank you. Yeah. God is amazing. There's so much. Man, I've been wanting to read more Bible and like soak my brain in the Bible and like retain it. I keep but I'm trying to live my life so right that I've struggled to find time to read it. I'm trying to read it every day. I managed to squeeze it in. Like I'm trying to manage stuff at home, trying to work efficiently and all this. But I managed to find some time to squeeze it in. Oh. But yeah, it's cool. You know what? I don't really usually dive extra biblical, but I picked up a book of Enoch. Man, I'm like, you know, we found out that like the book of Enoch was at least written before the time of Jesus, and it's got many Son of Man references and also references to like the righteous and the elect separately. And it's sort of, it talks about kind of you being restored in a glorified body as well. And you're like, man, this stuff is so similar. I'm only halfway through it yet, but it's given me so many similar vibes to like what's in Revelation and like stuff, and to think as well the Jews had this book in their collection, and it has prophecy in there about the Son of Man. You're thinking, man, they obviously had Jesus referenced in the Psalms and Isaiah and you know, and in Daniel, right? So many clear references of Jesus. But then in the book of Enoch as well, there's just so many more. And you're like, wow, man, to think, yeah, it's crazy how blind you can really be if you follow a particular theology or interpretation of the Bible. If you think about it, it's kind of nuts. Reading and listening to the Old Testament this week. Awesome. Yeah, Old Testament. Yeah, lots of good books in there. I've been more sticking to the kind of like the prophets. The major and minor prophets. But I think I've read Genesis a few times actually, but I've not really read so much of the other ones. like the Numbers, Leviticus, and Joshua. I really need to go back over those ones. I've only really read those once. I know what goes in on them. Kind of a very low resolution. But yeah, like the Deuteronomy, the Numbers, and Exodus. Actually, I read Exodus recently. But yeah, Joshua, Judges, those ones. I need to go over those ones again soon. Which books you been listening to specifically, Buffer? Right, let's start with some moss. We're going to stick another cube down. It's going to be on moss cube. Let's go. Right, so I think we need to add another, like... Oh, Kings. Yeah. Kings is great, because you got, obviously tells you about King David and Saul. Wait a minute. That's in Samuel, isn't it? Yeah, so it's after that. It's about Solomon, isn't it? Yeah. So it's after David where stuff just starts going away. Where all the false idols come in. Honestly, man. This is like where we are in today's history, Kings. You know? Especially the UK. It's like we used to be in the David era, and now we've come into this like the Solomon and post David. We're bringing the false idols into the country, rebelling against God. And sooner or later, Baal, that's it, sacrificing children. We'll be going, and the sword is coming to the land, take us all the way to Babylon. So, yeah, if only people knew. It goes slavery, wilderness, promised land, and then you mess up in the promised land and you go back to the wilderness or slavery. The way it goes. So we just make one of these brick files. Again, procedural materials. Code, modules, graphics. Lovely. So we're making copy paste. We'll call that Moss. It's going to be amazing. So I'm not sure what type of parameters we're going to have. So procedural material BR for brick. I guess we call it MO, right? So ASCII to hex. Not sure how much of this really matters, but here we go. Do it backwards. So OM MP. Yeah. So 50 for a 4D I meant, and 4D 4F. MO for Moss. Moss. Right, so moss material. Now what we need to do clearly is get some really nice pictures of moss. And not the brand moss, but the images. That's what you're gonna make. So you sort of get some like long moss or uneven or this sort of one, right? Yeah, it can grow quite long, can't it? This can be fun. I'm not sure how much we want to make it look like it, real, or just sort of like a vaguely. But yeah, this would be fun. It's a shame that beautiful land deserve better than that. Always pray for us more. Thank you. Yeah, when the UK is strong, the cup runs over. It's but yeah, we've been messing it up now. Now we're just spilling our cup. Basically, we're spilling our cup, and then our cup's got nothing in it. Anyways. Yeah, there's hope. You actually see a revival going. We got the Bill of Maine. Me and my wife are seeing it quite a lot. There's lots of people coming. Alright, just search around for brick. Those are some ideas. Brick. Yeah, cool. So we need to add another one here. Oh, not called brick. But yeah, like we're seeing quite a lot of people coming to Christ, because when we go out evangelizing, we'll bump into people who are like giving their lives to Christ quite recently. On stream, obviously people pop up and they're like, oh, you're giving my life to Christ quite somewhat recently as well. So we're seeing it happen. And also like what else? My wife was just speaking to someone. She went to see a doctor, and she's got like a cup with a Bible verse on there, Isaiah something, and she was baptized like a week ago. So yeah, the country is coming back. Yeah, revival's coming. Okay. So let's get a header. Let's start cleaning this up as we add another one. So SDF, PBR. Those are some noise functions basically. So we just slap another section in here and call it noise. And then brick. Not really in the best place, that is it? Calculate light radiance. That looks like it's in the complete wrong place as well. And that parallax occlusion map, which we probably won't need anymore, but we'll keep it just in case. PBR. Need that shading structure, not gonna lie. Let's put the types first, then the functions. Oh, what happened there? Okay, so yeah, now we can add another section called Right, so here's the end of the brick. So one section for the moss, then this one could be, I guess this is like the sort of public. These are like it's like the public API, right? It's the I don't know really, but you can call it the let's call it shading, if you will. Cool. So in here's gonna be moss, and we want to basically have a function like this. Yeah, it's gonna be quite like the brick actually. We probably want to, let's just copy the whole thing. When we've got a few of these, we can find the commonalities and build, build some shared functions, maybe like array marching function, that sort of thing. But until then, so moss material, we just got a placeholder for now. We're just going to do some noise, be noisy about it. Right, so anything called brick, swap out for moss. Cool, we're in a good place there. Right, so we could probably get rid of that. Yeah, I think we can get rid of this as well. What's going on here? Distance. Yeah, let's just get rid of all this until we need it. That's a Z. So input parameters, we'll probably need one of those. Ray direction, we'll need that. Lovely little ray marcher. Distance moss. So we'll just probably have a noise function in that distance function, which will be super cool. Calculate a normal, yes please. And then shading it would just basically be like, have we hit? Yes. Then coloring it, we could probably do another noise, but let's just color it as green for a moment. So red, green. One of that, yeah. Going to be a very ugly green, but let's just start there. Have you built first-person shooter games? No. No, I've not really tried to build one of those. I did like my first-person shooters and stuff like that, but yeah, they are quite fun, very fast-paced and stuff like that, but yeah, not really been died. Yeah, just not really been into making it really, or trying to make one. I think I went to a lot of like 2D stuff for a good while, and then I finally made the jump to 3D. Yeah. I was more into the idea of making like an RPG, I think. That's always been my sort of thing. Making those sort of simple RPG games. But I tried to make like a third person game before that was 3D. But it was more of like, yeah, so I tried to make this game where it was like, imagine a game like Rocket League, but instead it was with a hoop. And then it was one with cars, right? And it had a capsule. But the idea was you had, I'm not sure if any of this was a good idea, but it didn't. But it was just fun making it. So you could run around on the floor, right? It was my first custom 3D physics as well. And you could, yeah, you could shoot up a ball, and the orb, if you will go up, and you can tell it to stop. And then what could you do from that? Yeah, then I think you could teleport. No, that was it. Yeah, you can grapple. So then you can grapple up to that orb, and then you could then, while she was in the air, you could place walls down. I think, was this before Fortnite? I think it was. You could, maybe it wasn't. I don't know. But you could place walls down, and then it would end up keep placing more walls, and you'll be basically like ninja running across the side of the wall. And your objective was, what was there going on? I think there was like, yeah, there was this big ball. So yeah, it's like Rocket League, right? That's sort of just moving around the arena, and your goal is to basically hit it into these big old hoops. Yeah. So I tried making that. That was my first sort of. I tried to add networking to it, but then I kind of stopped. It was interesting. Oh, Gubby. Okay, so what are we going to next? Yeah, I think we'll just hard code a color. So it's a non-metal. And the gloss, no gloss. There we go. So, I wonder if we can add another material. And we can call it like, call it a flat material. Or generic. Or raw. Yeah, raw material. The raw precision material will just be the raw values passed in. Yeah, maybe we can add that. That might be useful. Yeah, since we've added moss, why don't we add one called raw? So this would be your 0, right? So if you end up on 0 accidentally, you get this 1. So raw would be... Yeah, I wonder if you can maybe have like a missing, or like makes it the 0, 1 just be an odd colored one, but anyways, we'll keep it like this. Right, so I think we'll do... So a raw material is just going to be like, it's going to have, I think floating point 16, maybe not, maybe just a full float for the color. Hang on it. Yeah, so that's sampled material basically. It's just these, right? Your diffuse. There's just a, you know, like a plain color basically, if you will. So you got your diffuse. So I think I can do U32 for diffuse, and I can pack in there. It'll be a color 1010. Mm, yeah, one of you do emissive strength as well. Is your emissive color, your gloss, and emissive strength. Yeah, so I reckon on the raw, we can just extract these guys out. You just call that an S, didn't you? Cool. The basic idea is this would be S dot this equal M dot that. Then your emissive is going to be multiplied by the strength. Now we just got to, there's a unpack RGB 1010.2, this one. And then it'll be a dot RGB. Fantastic. That's what you want. Then we should just be able to return S. So that's a good like material, like the zero material to be, right? The sort of first procedure material, it's just plain. You know, I guess you might want that in some cases. So let's go back to the moss one now. And get the basics going. Hang on a minute. Lovely. So we need a distance function now. So let's find the distance for the brick. How do you manage memory allocation in this engine? Right now I've just got two ways. I've got a static allocation or linear allocator. So basically I've got a thread local storage. Yeah, I'm not saying this is great. I'm not saying this is amazing, but it's just the way I'm currently doing it. So I've got thread local storage, and this doesn't really matter so much because I'm trying to statically link everything. Right, if you dynamically link stuff, thread local storage has a performance hit. So you want to try and avoid that. But because I'm going to, at least in the release build, everything's going to be statically linked, then it's fine and I'll happily pay the cost. if it's in debug, right? So we might dynamically link for debug because then we can pre-build things and, you know, it'll be handy. But in release, everything will be statically compiled in. So we use thread local storage, so we've got this lovely global per thread, and what's known as a static allocator and a frame allocator. This has static lifetime, this has frame lifetime. So this gets cleared every frame, and this one gets cleared every this gets cleared every frame, whatever that means. So maybe this is like a per iteration it gets cleared. And this one just stays around forever until the program quits. And you can you initialize them at boot with a certain size, and you keep bump allocating in that allocator. I don't have any heap allocators yet, but I do kind of. What else do I do? Yeah, I don't have any heap allocators yet, but I do have what's known as a range allocator. I have this range allocator, so it's kind of like a heap allocator, but it works with indices instead of pointers. So I use this in like my GPU buffers, but I also, because I haven't got a heap allocator, use it sometimes CPU side. So this is how I get away from not having a heap allocator yet. Is I basically do have one, but I statically allocate a load of memory and then I sub allocate using this thing. It was alright. I should make a proper heap allocator at some point. But this heap allocator is a good mode where it can return. It has some power of 2 buckets. So say if you want to allocate something that is 60 KB, what it would do is it will check the next power of 2 up, so it goes to 64K, and then checks the free list for that at that index at 64K basically, and realizes there's a pointer there that points to a 64K chunk or higher, and it will take it from there and then sub allocate, push it back on to the correct free list, and then we can go ahead and go about a day without searching through tons of different places in memory. So that's like an O1, right? It's like a constant. It's always guaranteed the same. Well, kind of O1. It's got to go over if that 64K has nothing, it goes to the next power of 2 and checks that. So it goes over a fixed range of, I guess you'll still call it O1. But it goes over a fixed range of different free lists, and since they're all next to each other in memory, it's super cheap to check them, basically. So yeah, it's quite good. So it's not searching, it's not doing a bunch of linked list searching effectively, but there is an option to do that because you might want to find the best fit. Yeah, super handy. And so, right, I think we can launch that now. Let's go ahead into the game. Or graphics, I think. There's the meshes. So let's add another one. I think let's push these two back so it's like. Yeah, let's just add these ones and see what's up. It should be there. Raw material. Oh, did I not include it? Writing any distance guys. Right, so we get one of these. Right, so I'm not sure we're going to have an out. We might have an out. We'll just add that if we need it. So a bunch of input parameters. Now, we can do a bunch of noise in here basically. We'll just return 1 for now so it always misses. Cool, hopefully that wants to compile. Nearly there. AO. 1. Right, what's this complaining about? Oh, so it tried to run. Right, material cache. Okay, so the lookup tables are not being filled. So here we go. It's not very nice. We're using C, so what designated initializers. These are the way to go. And my laptop keeps disconnecting from the chat. Okay. Lovely. So just gotta swap these out for the right ones, obviously. So this one will be raw. This one will be moss. Let's just type information, basically. That's all this is. Oh. Nice. I think that's got everything. We've not included the C files, is that right? Of course. Yeah, this is the problem with the code gen. Yeah, it needs to have ways to improve. But for now, just deal with it. Right, we seem to have broken everything. Oh. Yeah, just keep building up the tech there. It's fine, it's fine. Yeah, like until you have a considerable amount of things, it's fine. Build up the tech debt and then fix it. Fix it. Oh, right. So, what are we going to next? So, why then? Proto material name hash. Oh, that's a hard-coded 0 material. That's why. This is before I had. Come on. Proto material brick. The constants. Share between CPU and GPU. So that's why. No? That's not very nice. Can we tell all the shaders to recompile? That would be nice. Thank you. Right, still problems. No. Right, so what could else be the problem? So passing up the test material. Alright, maybe we're gonna have to dig into this. Are we hard coding the material? No, because that gets passed into the mesh. We've seen it. And then right, let's do some analyzing. So we want to see a few things, right? We want to see this being made. And we want to see when you try and fetch the RTO. It crashed yet. Alright, so we got a breakpoint. Yeah, procedural material 1, because 0 is the other one, yeah? It's the raw. So here when we try and make the GP reference, 0 is the block where it is, and then a 1. Good, okay, so that's looking good. So from a GPU side of things now, let's close that. So from the GPU side of things, if we go to scene shade, I think it is, there's a material in here somewhere. Right. So we find scene shade, is that it? Ah, here we go. Oh, can you see that? That's the right copy paste bug right there. See? So we should be proto material index. So it's doing 0, 0 rather than being 1 and 0. Perfect. So I've moved these two bricks back. So we're going to stick a super lovely moss block here. So let's get that in. The graphics VK, let's find the brick. So let's make a new one. We're going to call this test 1. And this will just be, I've just called it red. Right, we'll just call this one green then. And this will be the moss procedure material. So look for more brick. So this is the frame store properties. Yeah, so this will typically be serialized on disk somewhere or in some material library. I don't know how it's going to get done, but future Henry's problem. We're just trying to make some cool shaders right now. So we're going to fill in this structure called moss. It's got a placeholder filled for now. We'll be adding these in a bit. But for now, this will do. Now we simply are going to get the material from the material cache. And then we're going to store the properties. This is like a variable, like this takes an avoid pointer and it basically removes the header from our encoder system. You know, it skips after that memory and then, you know, it stores a bunch of U32s basically into a buffer that gets then uploaded to the GPU. And this is all heap allocated with that range allocator. That's all the material system does. When you allocate a new material in the material cache, it uses the range allocator, which is just a heap allocator, right? A free range allocator, and it manages ranges of U32s. So the moss material only takes one U32, so it just needs to allocate one. Whereas the brick takes 1, 2, 3, 4, 5, 6 U32s. So it has to allocate ranges of 6 for every brick material. So it's pretty cool like that, how it's, you know, works with different types of things. And yeah, so that should make a moss material. So all we've got to do now is make a new instance. So it's the moss material. We're not going to rotate it, I think. You know what, we'll rotate it 45 degrees. Then we shall keep it pretty central and bring it back to be quite close. We could probably do some spinning thing as well in the future, but for now this will do. Right, we see absolutely nothing because of the way the shader is. But if I were to simply change the depth value to be -1 to be inside, it should be green. Ta-da! Right, I shouldn't change the Y value, I messed it up. -1 on the Y. Cool. So here's our moss, right? It's just fully now this is where the fun begins. So we've got our lovely little ray marcher, which we probably want to, yeah, it's just like the brick one for now, but maybe we can make that more generalized. But anyways, we'll keep on going. So I think the cool idea would be just to ray march against some noise. So we have value noise, I think it's called. Noise 3D. You pass in your UV. Now I'm not sure how expensive his is, so hang on a minute. Let's get my boy up. Boy. It's a bit variable, which kind of sucks, but anyway, it's about 1.6. Alright. There we go. Right, that seems to have popped it up to 2.54. And it seems like the noise, yes, it's quite expensive, as we've seen. So it seems like we get a value from 0 to 1. I think. I don't know. Oh yeah, yeah. It's probably very low frequency. Oh yeah, low frequency. So let's make it higher frequency. Now, so my issue with this value noise is it's too expensive. Or is it? Hang on a minute. No, no, that's not that expensive. So as we've been doing stuff, right, it might not be that expensive because it kind of earlies out quite a lot. So what we want to do is the issue is you're seeing it clear cut. We should probably bring the cube closer actually, so we actually get a bit more of a full screen. So we go to graphics VK. Let's move it back. Yeah, I think this would be cool. Right, so it's right there in your face. So you're seeing it sort of a clear slice, and that's not very nice. So I think what we want to do is have a way. So if you start off inside the moss, we probably want to say, hey, get outside the moss. Right, I think that's a fair thing you want to try and do. So it's like your first loop is going to be, am I inside? So if D is less than min hit T, now I will say if you're inside, like actually inside. Yeah. Are you inside? And if you are, we want to do a loop, do a ray march until we reach out. Now this ray march, the problem is with a ray march that it's good at getting right to the surface exactly. So we want to actually step further than the surface by maybe an extra 25%, maybe an extra 50%. And until we reach out. So we're saying, so try, so escape the inside of the moss. So get the nearest distance. We want to say T T plus equals distance, I guess, multiplied by 1.5. Yeah, I think this is also a trick you can do if you're outside, but then like it has risk of skipping through thin objects Yeah, we want to try and get outside, so we times 1.5. Now, if we are now greater than 0, is the idea. Break. Yeah, and then do the proper rain march. Right, I don't know what's happened there, but okay, so obviously got a bit more expensive, but there we go. Right, so if we're inside, can I do a 2-5? Right, so this seems to be affecting it. If I do that, we're never going to reach it anyway, I think. Yeah, so maybe I think we never reach here. Although I don't know. So we can print out. Right, so we're going to do an if is mouse at shading debug screen coordinate print. Right, do we see a 0? Right, so it seems to be fine getting outside. Interesting. So if it gets outside, then is it not adding the distance? That's another thing as well. It should really be adding t. That right. So anyway, you go and carry on. Can we have more iterations? Is this part of the issue? No. Right, it's change the frequency of some of this stuff. Wait, is this? That's not changing anything either. Right, let's change the frequency of some of this. Let's make it maybe ×8. Yeah, so the one that tries to escape. To come back outside again. It does seem to do that. Uh, it does seem to get there, so what's the issue? Is there a discard that's going on? Okay, so you min hit T. It was greater than min hit distance. So is it anything like to relate to this? Okay. It seems like it's completely stepping out of the range of -1 to 1 somehow. So what is your T at this point here, I think is the safe thing to ask. Like what is T here? minus 0 point minus. Oh, hang on a minute. You're adding a negative value, so it's going backwards. So, okay, of course. So your D is negative. So you want to be adding the ABS of D. Already. Aha. Beautiful. Right, so all we did, right, is the following. This, we try and Raymarch, but we're Raymarching into a cube of some noise. And the problem is this the edge of the cube is like is like slicing straight through some noise, and that could already be inside some of it. So we're basically Raymarching through it until we reach outside of the noise, if you get what I mean. And then we can finally see a bit more. It looks weird, right? But it's fine. So now we're not seeing a sort of a slice going through some noise. Instead, it's going deeper all over the place, which is great. So now we just got to adjust the noise function until we get something very Moss-like, if you will. So I also wonder in terms of performance, though, this is it's quite bad performance-wise. It's added. Take care. Yeah, thank you so much. God bless you, Buffer. Thank you for popping by. I hope you have a good weekend and hopefully see you very soon. Yeah, God bless you, sir. Have a good one. Bye bye. Yes, here's the thing, right? So these noise functions are kind of cool, but they be quite expensive. Hmm. Right. So this is what I want to try and replicate somehow, if you will. So I reckon. So it might be good just to get some colors first. Right, let's probably see if we can get like a moss color. So we probably want that sort of bright one there. 65. The 65 is like 50% basically, isn't it? Roughly. Then 8B, probably around 70%. Then 3, 4, isn't it? Yeah. I am in a different color space as well, but that's a bit weird. That's not really. What seems off about that. Right. Okay, I think that looks reasonably good enough. Maybe a bit too bright, but it's better. Right. So, how could we recreate this using noises and stuff? So when you get really down to it, you've got these small like strands and stuff, right? They grow out and they clump together basically. So I'm wondering, but they also can be quite fuzzy as well, right? So it's quite interesting. So, we got these sort of noise functions and stuff. So one thing that we could do is you could do individual strands and then duplicate them with a different waviness. Sorry, you have a strand of a certain waviness, and then duplicate and have it rotated everywhere, maybe. But then I wonder. Yeah, it's interesting. I think what you're mostly interested at the moment is just getting the blobby nature of it, and then that sort of higher resolution stuff you can sort of bake into it afterwards. So what we're trying to probably look at is getting the general like a 3D volume of a nice smooth blob. I think that's what we're looking at first. Can we do that? So, unfortunately, hash, hash, hash. Yeah, it'd be cool if we could use like these hash ones, right? Is that even... They're just super noisy. Hmm. Wait, how can if you minus... Does it never... Oh, because it never escapes this, does it? Alright, and therefore it never renders. Okay. Right, so it never escapes, then I guess... Anyway, something to think about. Cool. Right, good to know about. But yeah, so this sort of hash value... Right, if you get rid of that escape code... Yeah. Cool. Right, so this one's not a gradient noise. Yeah, we want to have really gradient noise. Now if we... Right, so see what we've basically done. Yeah, so I think what you're seeing here is... So if we got rid of this, it doesn't remarch outside the shape. And you see these edges. Here we're trying to remarch through it and get out the other side. But the issue is sometimes you see these pieces of it, right? So we want to actually say once you're greater than min hit t, then can you escape. Something like that. But we're still seeing outlines here, which kind of sucks. So I'm wondering whether or not that is... Hmm. Alright, it's better than it was at least. But yeah, we're still seeing the walls, if you will, kind of. Let me see if I can... Can you even do an and false? Cool. Right, so this wall here, we still kind of see it, which sucks. But I wonder if we up the frequency of the... the noise. Oh, too much. Right, it's not really changed much. Okay. Yeah, I'm not sure if this is the right approach to go. Right, what else have we got? So effectively what we're looking to try and do is get sort of a bubble-like... Maybe spheres, then. Right, what you want is spheres to be placed on top of spheres. And... yeah, then from that... Yeah, I think that's what we want to try and do, right? Because essentially you're... yeah, spheres on top of spheres. Repeat those. And then once you've ray marched and hit the sphere, you can maybe ray march into a surface where you've got these sort of strands if you always get the higher fidelity. I think that's what we want to try and do. So where's the ray sphere? We've got like grids as well. We can do like an infinite... repeat. I think you want to layer that up a few times. Yeah, it's the kind of repeat in nature though, maybe. Yes, SDF sphere. So start off with this. So we've got a... call it GUV, we'll call it a gov. And a radius, we'll sort that one out. I don't know what we'll call that, maybe a scale at some point, but let's do 0.05. Maybe it's a bit small. So that'll get you back a distance. Now the gov is going to be made via an infinite That's a finite. Hang on a minute. We want an infinite. So the spacing is probably going to be, well, I don't know. It's probably, so it's more built up on top of each other. Right, start with this. Um, Well, so UV take break offset. Okay. Um. Right. The spacing needs to be bigger. Cool. Right, so it seems like this is trying to remarch through the surface. I think. Yeah, so here is collide. You're inside the shape automatically. So this is trying to remarch out. And therefore it creates that effect. Okay, so it seems like what we want to do basically is probably not have this then anymore. But it was an interesting take. Right, so those hard edges we probably will just get rid of by basically doing the spacing thing anyway, right? Doing the spacing right. Anyway, that doesn't matter so much. So this. Okay, so imagine if we had a grid of. So you want to somehow create maybe a non-repeating pattern of clumps of spheres. And the clumps of spheres must. Or you can do smooth unions as well. Yeah, smooth union of spheres to create a mossy like surface, and then within that, if you hit that, you can then strandify array marching into those spheres, I think. Maybe. So if we were to, yeah, so the thing I've got to figure out is how do we make it repeat, but then also have different. So you could do you could do different. So you can change the spacing, right? So you have spacing 0, spacing 1. So maybe there's different grids of, one grid is like, you don't make them even numbers, right? So one's like, hey, I'm 30, we did 39, right? So, or is this 4? And rather than being 80, it'll be some odd number like 52, right? And then you can then take a smooth union. Right, we don't really have smooth unions. Let me get one. So smooth union. Oh, that crashed. What a shame. Right, let's bring these boys in. Right, so lovely. Okay, so SDF smooth union, or I could say union smooth. And then AB intersect smooth. Lovely. Lovely. Right, so where we do our mass distance, we can now do D0, D1, and smoothness. Now, hopefully, oh, right, clearly that's too much. It's a distance-based smoothness, I think it is. There we go. Cool, so we should have two grids, but offset from each other but they're not double, yeah, the different spacings. So we bring this down. All right, so the problem is it's doing, Right, smoothly merging with ones outside of the bounds. So with that, we've got to we've got to make it finite. So the bounds we have to work on based on the spacing and the radius. How we're going to clip those ones out. So min max. Yes, the bound. So call it bound 0. Your bound 0 is going to be how many times? So you got 2, which is minus 1 to 1 distance of 2. How many times does radius? So you got a radius and a spacing. Oh no, it's how many times does spacing fit in there? Basically, spacing 0 fit in, and that's your bound, I think. We have a bound 1, so it should stop repeating up to that bound, basically. And no, that didn't work, so maybe it's half that. Right, something's happening. Do we time 0.5 or something like this, or? Well. Right, let's start simple. Let's get rid of the 2 bounds for a minute. So, can I just talk about the first one? Right. Let's talk about the second one. This one goes out of bounds, right? We want to clip those ones on the edges out, right, where they're sort of being clipped, these ones. That's why we're bound. So, that's doing something. Right, I think that's working. Good. So, we've got to get the right number though. So, is it saying how many times it can repeat, isn't it? Right, let's change the spacing a bit. It's looking kind of cool, but yeah, I think something's a bit off. So maybe it's not. Right, let's read the code again. So it's sort of dividing it, clamping it. You're dividing by the spacing, clamping it in a range. Oh, interesting. So, wait a minute. Yes, you're saying how many of the, right, how many spheres can you have? Okay, so Yeah, so I thought I was working off, right? So 2, right? So say if you've got a range of 2, say if your spacing is between each sphere is 0.5, right? So you should be able to fit how many, right? 1, 2, 3, 4. Yeah, it's 4, right? Because there's 2 halves. There's 4 whole ones, right? So this bound number, yeah. So the issue is because your grid. So you've probably got the right number, but everything's centered. Um, so you probably need to take 1. Can't be right. Hmm. Right, I think you want to make it go -2 to 2 type thing. So, aha. Right, you have to half this. So after you half it. Okay, and then I guess you do a take 1, then that gets it 3 on one. Yeah, okay, got it. We got the maths. So, yeah. So that is the maths. So we up this. Well, right. So when there's sort of whole integer divisions, I think it works perfectly fine. But when it's not that, for some reason it doesn't. Now if we, not very nice, is it? See, I think we want to, so we have that. Is it some kind of like rounding to the nearest integer that we need to do? Right, there is. So, right, but why isn't there any, I'm going to do 4, 5. Yeah, okay, so we do see them move. That's great. Okay, so this is what we want. We'll have a grid of spheres that changes based on obviously the spacing between the spheres and all that. Now, yeah, that's exactly what you want. Lovely. So we're gonna have 2 grids, right? Now that there are different offsets such that you can merge them together and it makes it look irregular, right? You're breaking up the patterns by having 2 different grids. That's the plan, right? So here we go. Boom. Now, you probably want different sizes as well. That's another thing. Right, so maybe what you actually want is probably like a radius. Um, yeah, so one's going to maybe be smaller, the other's going to be bigger, whatever, right? Okay, so what are you doing your radiuses? Okay, probably a bit too small, so we can do a 10 and a 10 and a 15. Now, these grids are a bit... Yeah, I wonder if we could do like 3 different grids. Some big ones, some small ones. So the problem with a big... Hmm. Yeah, so maybe we can do different things like a smooth subtraction, a smooth union, and get completely unique shapes. Yeah, so 3 different grids. I don't know about sizes of things. Let's make 120, for instance. Spacing as well. Let's make that 56. Do another spacing. And then what's great is some of this stuff should be able to be shared so we don't have to keep doing it every ray march. So you can get your distances. So we're going to do a smooth union, and as you guessed it, another smooth union. Okay, so there seems to be stuff happening. But there seems to be the spheres seem to be a little bit rogue. I don't know which ones those are. They're probably... Yes, the big ones are merging with the second. Yeah, so 3 are the big ones in the middle. They're a bit... Hmm. Yeah. Hmm. Yeah, maybe we can make some of them... Oh. You see, though, isn't it just going to create patterns? Because... No, they are going to be different. Yes, I wonder if what we're looking for is like... This, what we're kind of doing is kind of like a fractal Brownian motion in a way, I think. Right? Kind of. Would we say we're doing that? Because it's like when you inline an FBM. But then instead of doing a noise function, you're just doing a sphere that's repeated. And then we're smooth unioning the result at the end. Yeah, okay, so maybe we could make a thing where it's like, you know, like an FBM, we have like a, a, a anyway, some of these parameters, like the lacunarity and all that, lacunarity and amplitude and gain, maybe, and then it just calls in and outputs a distance function. But I think inline is probably fine. But yeah, you could tweak all those few different parameters, right? And then it should inline automatically. But yeah, say if you did that, you know, I'm wondering if we should have some which sort of like subtract as well. Like if you did a smooth, imagine if the last one was a smooth subtract. Right. That wasn't really that interesting. But maybe a smooth intersection. No. But yeah, so I reckon we're on something here. We just got to tweak the numbers to be right because they're not the same. I think. Well, maybe the edges are. You sort of seeing the corners. Maybe they are the same. No, yeah, I think it would be a repeat actually. So to make it not be a repeat, there needs to be an offset to the grid. Yep. So you need some kind of random offset 0, right? Just some numbers. We could say now it's got to be related to the probably the radius in some way. Yeah, so I reckon we can apply space. So yeah, plus offset 0, offset 1, offset 2. So the way we can do it is basically offset 0 is equal to spacing. So if it's equal to spacing 0, then it's going to definitely change. But then the bound is no longer going to help, is that right? I don't know if this is going to help. Let's see what problems it causes. I think what problems it's going to cause is we're going to have those edge issues again. But it's going to fix the... Right, so what we would like to do is make one of them affect the X, one of them affect the Y, and one of them affect the Z, obviously, right? Alright, so here we go. So you do a 1, 2... Interesting. Right, it's got to be a dot X, a dot Y, and a dot Z. Right, that's irregular. And it appears to have not got any cutoff, I think. But it is weighted towards one positive direction, I think. So we probably want to do a few negates somewhere. It's part of the issue in it. So maybe you can do a scaling type thing instead. So it's like a scale, and that way it kind of goes outwards at a different rate. So maybe it's a scale. Clearly a bit too much. So maybe a scale then would be not based on spacing at all. Wait, but then if you scale, there's no... Yeah, the ones in the middle stay the same, but I think... Hang on. Wait. Will. Okay, so... Do we want to make it look like it's shrinking then? That looks like it's shrinking, so we want it to maybe be 0 0.9, 0 0.8, 0 0.7. Is that too much? Right. That looks irregular-ish now. The issue though, you get the problems where I think it's got to be based on maybe spacing. Dot x. And how much does half of it fit? Yeah, so in the units... So given the bounds, how much space for that grid of spheres, the spacing between them, you wanna... Yeah, it's the issue, isn't it? You wanna... As soon as we grow and shrink these things, they're gonna automatically go outside at a certain point. Yeah, I think this is the way to go. We just gotta make sure they don't go outside, and I think the bounds can help with that. Effectively, we need to work out this sort of like... Is it a scale though? Well, the scale can produce ellipses as well, right? So that could be quite beneficial. So you know what? If we put these custom scales in X, Y, Z, then yeah. Then the scale could be applied maybe to the spacing as well. Maybe... Hang on. Yeah, but that's going to create it a regular pattern again, isn't it? Hmm. Yeah, so maybe we want both an offset and a scale. So that's not right. All right. Yeah, so I think one of the problems with this technique is you can get some dangling spheres which are not attached to anything. So what we should probably do is make sure they're not spheres. They're more ellipsoids. And then you mash the ellipsoids together and then they make these like areas of moss, right? Then these areas of moss can then be added detail on like the hairs and stuff, which will be cool. But we've got to be careful because we want to avoid taking too much time and computation. Right. So yeah, I think definitely interesting. How expensive is this? It's not too bad. All right, so I wonder if we could provide some kind of other way of doing it. Like the FBM where you got those different parameters and you're choosing how to modify a noise. Right, so how could we sort of make this into a function? Well, you got the UV and we're looking for that UV to be it's gridified into these different grids. The noise function would basically offset the UV, but we do kind of want to offset the UV just a little bit, maybe give it a different offset depending on the grid. But every time you go through an iteration, you're on a different grid, and that grid will have a different degree of spacing. And a different degree of spacing and probably a different scale. Yeah, but you could probably get the grid index you're on and actually create different looking ellipsoids. Yeah, I think you can do that. And you could probably create different sized objects as well. All right, got me some ideas. Because you can get a bound index, right? You're already doing the maths for it. Yeah. Right, got me some plans. So what we're going to do is be inspired by the FBM thing, right? Fractal brand in motion. So I think we can basically get a distance. And are you going to smooth? I think we'll smooth union them. So you're getting you return a distance. I would just call this a MOS ellipsoid, if you will, or grid, ellipsoid grid SDF, yeah? So I reckon we pass in our UV, we pass in probably some kind of spacing value, and the bound could probably, yeah. Yeah, but the bound you want to be pre-computed anyway. You probably want to pass in the bound just so it could be pre-computed based on the spacings. But yeah, the basic idea is it would be a sort of a grid UV like this. But actually, what we probably want to do is inline it such that what we can actually get is some kind of index. We can call this the coord, I guess you'll call it. Now, grid UV. Lovely. With coordinate, you can offset by spacing. And this gets you a 0 to bound times 2. A 0 to bound times 2 value. Right. So with that coordinate, now we could change the radius and the... Yeah, so we could probably do... So within the spacing, we pick 3 different radiuses based on the coordinate. Probably. And you could probably do a very cheap... Yeah, but then if it's based on the coordinate, they're all going to be the same. So you could do a quick hash. I don't know. So spacing You probably fract it. Yeah, fract it. A quick, yeah. So coord times spacing. What does that get you? Let's get you a position now, doesn't it? I think. Hmm. Uh. Yeah, I think that just undoes it, doesn't it? Yeah, that just gets you back up into. Hmm. Times it some by some big, and times that by some big number, and then take the fraction of that. Is that a prime? One. Yeah, 137 is a prime. Cool. Yeah, it felt like a prime. That's great. So 137 is a prime. So we can maybe fract that. So we get a fraction of that. And we can use that. We've got 3 different fractions. Right, let's just do one of these for now. I think let's just return that for now. So UV, whatever the spacing is going to be, let's say vec 40. And the bound, screw it. We'll pre-compute the bound as well. So do. Excuse me. Oh. Yeah, so we just want to return. Yes, the radius here. So we need like an SDF ellipsoid. I think you just stretch it out basically, but we'll get another one in. Not true SDF, that's alright. Right, SDF 3D ellipsoid. Alright, I'm happy. Cool, so you've got a radius of vec 3 here, so let's see how that looks at least. Right, horrible. Hang on a minute. A fraction of is a spacing multiplied by that. Whoops. Okay, so what's going on? So we just take coordinate. Times 0.5. Right. Um, right, for coordinate would be hmm. Coordinate plus equals spacing. Oh, spacing might not be it. Plus equal bound half. What's going on? No, 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 no. That must be bound half. What's going on now then? Hmm. Around the nearest int. Um. Should be right. So we've got fraction of that. Is that always one then? Oh yeah, a fraction of that will always be one at that point, wouldn't it? Because yeah, so we times it by spacing, but then it would always be right. We're getting some ellipsoids there. That's kind of nice, but why? That's great. They're kind of irregular there. That's what we wanted. But why is it being so dodgy? We did a fract of that. That should just be 0 to 1. So I guess we're inside an ellipsoid at that point. But that's why we did the bounds. Hmm. Um, so these green bits are obviously hitting inside of an ellipsoid or something. Seems that way. Right, why don't we just do a fixed radius, which is spacing times 0.5, right? What does that do? Ta-da. Right, so for some reason, picking a fraction... Oh, is it negative? Right, is one of these negative or something? Right, that's interesting. Right, so there's some negative values, but that's still not the point. So I guess if we times by 0, does it cause us problems? But that's fine. No. But minus really causes too many problems there either. So what's going on? Is it because it's just such a big number? Yeah, so why is... Oh, half a bound. That's kind of wrong, isn't it? Right, okay, good. We're getting some progress. So if we ABS this... Hmm. They are different depending on the... Is that a problem then? Is it a problem to make these spheres different depending on what grid cell they are? I don't think so. It's not a problem as long as they're not bigger than the grid cell itself. My understanding. Or don't approach the grid cell size itself. That might be what's going on. That's super bizarre. Can I get rid of spacing? Right, so if I did like a vec3, 0 0.2, 0 0.4, 0 0.7, what does that do? Total. So that's okay. So if I made it 1. Okay, interesting. So 1 know that. Hmm. The coordinate is bound. Right. That could be a problem. Okay, so I think not the issue is it's the bounding thing. Right, I think. No? Because like yeah, we're seeing this box on the edges. That means when you see through the other side, you're also seeing that same map. Now mm, yeah, something to do with this coordinate parameter because we get rid of it. Right, I see. So maybe the coordinate parameter changes as you're stepping through, so it causes problems. Right, let's hang on a minute. If is mouse at screen shading screen debug coordinate. Right, let's have a look here. Wait, debug screen coordinate. I should just make this shorter. Anyway. Right, print me out the coordinate, please. What do you see? Got some zeros. Right, still zeros. That's the problem, I think. Whole bunch of zeros. So we added 1. Time spacing. Right, we're still getting something here. They seem irregular now. But we're getting those artifacts. Probably because the max step size has been reached. We can test that by upping it. Nope. That's probably because we've stepped too far. So the step should be limited to, here we go. We need to limit the step size, like we did in the brick one, to a grid. Yeah, there's some that we need to, so we need to either limit the grid or we need to limit the grid and or shrink this a little more such that it doesn't reach the boundaries. Yeah, I think it's great that they're it's getting quite expensive though, I don't know why. Maybe it's the amount of steps that it's having to do through this grid of, yeah. These pixels here, they've stepped through so much and miss. But that's not gonna be a problem, it'll be cleaned up by the time we have more things going on it. Okay. So these little glitches, we've got to fix these, but I like what it's doing, right? Different size ellipsoids in each grid cell. That's powerful. Because then we can have layers of different grids and then smooth union it all together. And that should create a weird, like a nice sort of like rounded geometry, which we can then call moss, right? That's the idea. So we want to probably have a minimum, some kind of like min min radius or radius min. So I'll just be spacing times 0.1. Think. You want to say, pick the maximum please between radius min and this, yeah, cool. So I think the basic idea is you don't want to step more than that. So you want to make sure your step, right? So you get your distance here. Now pick a distance, return d, d equals min between d and radius min. Ooh, I'm wondering if that... Does this even help? Yeah, it did help. You see, you got rid of the artifacts. So what is that number? Like, if effectively we've got a grid, and as we ray march through the grid, we're changing the geometry, right? Such that when it reaches the next grid cell, it's like, oh, the sphere, the ellipsoid is completely different, right? And then you end up basically being stepped inside the ellipsoid. Big problem. So to avoid that, we could also pick a maximum of the radius and make it 0.4, but then you can still step into it. The real bugger. Or you could align yourself to the grid every time, but that will still be a bugger as well. Yeah, I think you want to do something like radius equal the clamp of radius min max, basically. Something's complaining in it. What's complaining? Right, there we go. Radius. Oh, radius min never worked. Oh, great, 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 great. This is good. This is really good. So, what we should have picked is min distance. Or min element. And that solved it. Amazing. What about ×2? Can we do? Right, that's where we start to see some artifacts. Yeah, you see those stripes there? There's one here as well. We can make it more apparent. Right, so that is the number we need there. Lovely. So, again, I need one of those comments. Here you go. Max step is needed here because the UV is offset. Because the underlying geometry changes when it enters into a new grid cell. Stopping it stepping too far prevents any artifacts. Bam. But obviously it takes more, it decreases the performance. So that here, 3.39. Now if we get rid of that, it goes to 2.86. But that only is providing wins right now because we're actually stepping through the whole area. But the moss isn't going to do that. The moss is going to be a big old clump of things, such that I think we're never going to be marching that far through it anyway, right? So let's see how it goes, yeah? Right, that's good. So now what we need to do is define different grids. And then voila, basically. That's the idea. So we did have it hard coded like this before, but I think that's a little bit. So we used to have it hard coded. But yeah, I think that's a bit crazy. Maybe what we can do instead is have something like the FBM, and it produces arrays of spacing, arrays of bounds, and those just get passed in. So I think we can have pre-compute a maximum number of grids, maybe 3. So we'll define it as grids count. Let's just do 3 for now. And I reckon we can do a lovely for loop. And the basic idea is we just want to smooth the union, all of these guys. Like we can do like a D. Something like that. So on the first iteration, this kind of sucks. Yeah, but no, be inlined anyway. So D equals SDF, else. Okay. So it'd be unrolled. Get rid of all that. Right, so needs to return D, yeah? So the basic idea would be you got to pre-compute random spacing. Or maybe not random spacing, but the idea would be it's different frequencies basically. You store them in the arrays and then you pass them in, yeah? So or maybe you don't need to store them in the arrays. That's a dumb idea. That takes up some spaces in the registers and they'll be done. So the idea would be you start off on some spacing value, right? Maybe the initial value would be like 4. It's kind of inspired by the FPM, right? Then you simply compute the bound, pass it in. Right, maybe it doesn't need to be passed in now, you just pre-compute it here. We compute there, hopefully it's all in lines and done. Now, spacing then needs to be modified by some kind of value, like how much do you want the grid to be changed? 1.2 times, let's say. And that should be something we can start off with and we can just keep tweaking it now. Right, smoothness doesn't exist. What did that used to be? 0.01, okay. Right, so as we change this, I think we should start off on smaller grids. Wow, that's interesting. Too small though. So, although the small is kind of what you want sometimes, and then you just want it to get bigger progressively. Yeah, I think this is what you want basically. But find the right magic numbers. So maybe we need more grids, like 4 grids. But then that makes it damn slow though. Right, this is actually super slow. Doing this, unfortunately. It's about 5 milliseconds. But we're hoping to make this sort of stuff more performant in the future anyway. By doing some low resolution ray marching. And we've got a lot of near misses here, so what we should do is make it more clumpy. Should we? Hmm. Yes, every single time you add another iteration, it does make it really bad. So SDF ellipsoid is doing some lengths. And those lengths would be some square roots in that, right? See, I wonder if you can just stretch. Do a sphere and just stretch. The local space parameter. We did that before. It's questionable. Right, switch it back to sphere for a minute. So radius.x, the ones that we did, that fract thing. Yeah, so you are sort of getting some ellipsoids. What are we doing? The min radius? To the min element. Right, yeah, the performance difference by picking a sphere and ellipsoid is enough to warrant the change, I think. It's just a question of, so the length is quite expensive. I reckon. So what happens if we did a squared length as well? Does that would make a different looking shape entirely, wouldn't it? But maybe it might be doable. But yes, if we modify the grid UV such that it shrinks, it can create probably an ellipsoid. So I reckon 0. Let's try 0 0.7, 0 0.8, 0 0.9. Right, so as that number got smaller, the thing got wider. Right, so it's sort of like an inverse thing. So do 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 do. Right, so what would you call this then? Yeah, so if you had it as 0.5 of spacing, right, so let's just make radius 0.5 of the spacing. And your spacing is probably actually going to be even at this point. Yeah, you know what? I think spacing should just be one of them. That will help with the performance as well. So your bound could, it's less registers. Although we're seeing it as a constant, so it's probably not going to help in terms of the numbers we see now. But if we were to make them variable, then it would keep it this similar. So spacing. Yep. You need to vec 3 of these guys because it's not going to like using scalar and vectors in the same function, unfortunately. 3D coordinate, spacing times chord. Yep. Right, so spacing is here. So radius scalar, please. Now, when it comes to, so we want to take this fraction thing and we want to call it, I guess this is like your scale or something like that. We'll figure that one out. So yeah, so if we just did scale, no radius min anymore, so that should just be, I think radius might be it, but we'll see. Oh crap. Okay, so if we get rid of the time scale, what happens? Right, they're just big old spheres. Cool. So your radius needs to probably be a quarter of spacing. Now we can stretch it. So we do the times by the scale. So the issue is we want to make sure that this scale never goes lower than 0.5, I think. So we want to pick the maximum between a vector 3 of 0.5 and that, okay? Cool, so 0.5 is a bit too much, so a bit higher, please. Yeah, so I reckon we can bring it down a bit more and then offer a little bit more room to have it ellipsoid. Yeah, there is actually already some ellipsoids. You can see them you get quite a lot of blobs as well. Yeah, you see them here, see? They do exist. Alright, I think I'm happy with that. So, cool. So this gets us something. I wonder... So you got some 0 coordinates. I think that's helping produce some bigger values, I think. Because they're just getting 0, they're just getting this fixed number here, you see? And they're all getting the same ones along the x or something like that. So... Yeah. So, what can we do to help that out? Coordinate times spacing, and a fraction of that. So, we add like a 1. Times, plus a little bit. Times, I don't know, 2 point whatever. What happens there? Yeah, so it's not really changing. I think these are the zeros. But anyways, I think that's helped with the performance. So we added... Oh, that's not very nice. More grids. Yeah, it's come up very sphere-like, isn't it, unfortunately? Oh, that looks interesting. Maybe we just go full high frequency. That's not too bad. Yeah, maybe we just go full high frequency spheres everywhere. Obviously, we'll make them a bit more ellipsoid. You know, and then we can add some noise. Maybe. Yeah, you can see the grid, it looks a bit weird, but anyway, I think we can try and make them ellipsoids again. Don't know what we messed up on. Hmm. Get rid of this max for a minute. Put a 0. Yeah, you're sort of seeing ellipsoids here now, so... Well, a max is the wrong thing to do, right? Max's clamp is removing information. Fract is 0 to 1. So what you would rather do is say, hey, I want 0.4 bits of information. Right, so 0 to 0.4. And then I want to offset that by 0.6. I think. Yeah, land a value between 0.6 and 1. But then you're not really getting what we want. Spacing. We did make spacing a float though, didn't we? Rather than a vector 3. Yeah, but it's already a uniform value anyway. Hmm. Not sure what we changed. We could do some printing. So radius is spacing times 20, then scale is a fraction of this. Coordinate's the only vector 3. And we've made it 0 to, well, it'll be 1. 1 point something else, then. Yeah, right, let's change that a bit. Yeah, something feels uniform about it. I don't know what, though. Hmm. Right, can we undo it and see where it was last? Right, that was like ellipsoids. What changed? Messed around with this stuff. We got rid of the max. Yeah, the max shouldn't have done it, so we made it 1 though, but still. Uh, so spacing 0.4 and 1.8 on the multiplier. You're sort of getting stuff looking like spheres a little bit, but these be a max, wouldn't it? Right, let's copy paste the function. Hang on. Okay, reload busted. Or did it? Oh, interesting. Right, so we've got some ellipsoids there. So let's take this. Yoink. Get it back to where we were. Now what's the difference? Ah. A scalar. So it must have... Nah, can't be it. Right, so maybe using the clamp is the right thing to do. Yes, the issue is that the one where it goes... I guess this is... I'm not sure what coordinate that one is. We can double check it quick. So we want to know like what the bound is for that. Or chord. So I'm going to say is if shading is mouse at debug screen coordinate print right, so be -1. You can offset it by bound. So you can make it 0 to 1. Right, so that's 4. This is 0 0 down here, yeah? So yeah, there's something about when it becomes it. Can you see how these ones are going that way, these ones are going that way, and these ones are sort of a flat, become more flat. And this is a sphere and this is another type of sphere. So there's something to do with the way the coordinate works that it's causing. I mean, another big prime number or something. Hey, Devros, how's it going? Yeah, I got the transparency working. So we did order independent transparency in the last stream. It's pretty cool. So we've got a layer buffer, we call it. So we use the here it is. Yeah, so we've got a thing called a layer buffer. So here's the first layer. And here's the next layer. And it's got this is the depth buffer. So there's 4 layers of depths, and there's also an object layer as well where it stores the objects. There, so it's like a 4-layer visibility buffer. That's all it is. That's all it is. Nothing special. And it uses the extension pixel interlocked unordered. So all we do is lock the pixel, load in the 4 depths and the 4 objects, and essentially do a reverse search from the back and try and find a place to insert it whilst we're finding a place, we're shuffling it to the right, and then we insert into the final location and write everything back. So effectively the trade that we've made is, the way you can look at this is like a 256-bit G buffer. When you add up all the 4 layers of depth and color information of the object information, it's 256 bits. So the trade is basically, rather than doing a G buffer, it's doing a 4-layer visibility buffer, and then the shading happens in deferred still, right? But it has access to 4 layers of information. So yeah, we lose access to early Z here and all this, right? Also, we lose access to render target compression. But yeah, anyway. So the other thing is, but yeah, the benefit that this gets us is when we've got this moss material done, we're just trying to get the initial shape of it and then make it look super cool. But when we've got this one done, we should be able to layer the moss on top of the brick. And then we can do an optimization. You know, the cone tracing optimization where you SDF ray march at a lower resolution? And that should make our scene shade far quicker. That's the hope. Yeah, we're just going to make some more materials and then we'll do the optimization. So the transparency, the order independence transparency that the layers all have, it has two purposes, right? Transparency and low resolution pre-stepping for ray marching materials. So yeah, it's going to be cool. It's going to be cool. Gonna be super cool. Right, man. Yeah, there's something to do with this coordinate. It's like we're not getting the. Well, you know what we could just do is print out the. What's all the different scales we're getting and why. This scale is 0.5. It's all the same, right? And that was all the same as well. Of course. Right. It's all so obvious now. There seems to be, obviously, if they've got the same values. Yeah, so we could do, the spacing is uniform now, though. How could you make this non-uniform? You could make it a hash, but then bum, 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 bum. Yeah, I got an idea. So you do the PCG hash, whatever it's called. Or wait, you do a float hash. No, no, no. Yeah, so you int car, you just do this, right? You do a you combine, you flatten the coordinate down. That'll just be like a, call it a, then I think we can just like ucoord times bound times 2. Dot y. Something like that. This gets you a hash. Then you simply just take the 4 different values. You just take 3. It's like a unpack unorm, right? That thing. This one. Dot XYZ. Now that's, then you just times by 0.5 plus 0.5 to make it a range between 0.5 to 1. Hang on. Oh, hang on a minute. It's got some point Fs in there. So bound should really be an int. It is an int. That's the problem. Right, let's make bound an int because it is. Yeah. All right. That's working. So now we've got these sort of, yeah, we just got ellipsoids, right? We've got, and they're all, you can't see a pattern in them. Nice. So we up the number of grids and you just gotta, it's like FBM, right? You just gotta monkey around with the gain, the Laranacrity, that sort of stuff, right? It's similar in that sort of sense. Right, and you can get a sort of a blobby surface, which is what we want. Get some blobs. So we just got to figure out. Yeah, so something like that. Maybe. It needs more, bit too much smoothness, I think. Yeah, maybe the smoothness needs to be changed. I don't know. Yeah, just having like. Yeah, I'm just trying to think about. So you put this on a surface. So we're trying to paint this on top. It's like a volume, right? So say if you hit this point here on this brick, and it will like. And then we try and apply the next layer on top, or be here. I think we'll try and basically. Yeah, still got to figure out that logic. But yeah, I think you will basically just make this a little bit more high frequency. Something like that. And then 'a little bit too small of a grid. Mm. 1.5 is probably not a reasonable number, but you want to pick maybe some weird number. There's no pattern to it. Then yeah, so the way we're trying to look at it, there's gonna be these islands of moss, if you will. That's the sort of aim, potentially. Right, so here you have this sort of like rock here. So imagine if you've got this brick structure just wedged into this, then only the moss spheres, if you will, the surface of the moss is that pokes over the brick will actually show up. And because it goes inward, it means that it doesn't always. Yeah, not the moss always doesn't show through, right? So I think this is basically what we want. And then we just want to find a way to add sort of more of the hairy detail to it if we want to go that far. That's the basic idea, right? So you got a choice right from here. Yes, I think this is good. I think we should leave it exactly at these values. It's about 5 milliseconds, right. What happens if we just do nothing and just return, I don't know, 0, 1, right? So 2 milliseconds for the bricks, and it's costing 3 milliseconds just for this. So, yeah. But we didn't make it go anyway. Yeah, I wonder how much of this we could pre-compute and then... But maybe not. Yeah, there's probably different optimizations you could do with this as well. You might be able to pre-compute a... Wait, hang on a minute. Yeah, the ellipsoids are all going to be the same shape. That's a problem. Hey there, Ultra Scientism, welcome back. By the way, is there any kind of caching for your 3D materials, or is everything real time? No, it's all super real time. So yeah, it would allow for... What it allows for is completely different, completely unique materials across the whole scene without encoding them into image data. So it's purely compute bound, basically. Yeah, so this is an SDF that's been ray-marched into. It's just a cube mesh ray-marched into. So it's the 3D volume of SDF, basically. Yeah, that's the plan. So we're going to try and optimize it by adding some caching in the future, which would be the ray marching itself, right? Ray marching at a lower resolution, stepping most of the way. Because if you take a look at the where are you at? The bloom image. If we go down to a lower MIP, let's say 3, so that's 8 divided by 8, right? That's 8 less resolution. You see, you're already seeing similar distances for these guys, right? So you should be able to step most of the way at like an eighth of the resolution, which would help out a lot. Would have to just make sure that not that much maybe. So yeah, pre-step and a pre-pass basically. Yeah, this is concerning. This is saying... Oh, crap. That's not really concerning. What can I say? It's... the shapes of the... We want to make sure these shapes are... This hash is different, right? Because the hash is based on the bound. Yeah, but it's based on the spacing, actually. And if you're... No, I think it's fine. As soon as the number of ellipsoids changes inside a grid, it will produce a different hash, depending on the coordinate. See, that should be fine. Kind of. 0, 0 will still be the same. Yeah, I think we might want to add some kind of like offset to that maybe. Um, so I think we can pass in like an eye. And then just do like big old. Oh, wrong one. Space in. So British. IG, where's the IGs? Right, we just make the ellipsoids all look very uniform now. Oh yeah, times by 0. Of course. I think that's made it a little bit more irregular. Okay. Yeah, so where's the performance problem coming from? Is it this sort of like, can I try just write the word scale in there? And do maybe like a min element? Take 0.5 maybe and just see if that changes the performance. Actually, no, this is a very bad test because when you have a different distance value, it changes the amount of steps you take in array march, meaning we can't simply just comment stuff out, really. So another cool thing to try would be if we made it sort of like a dot of itself, did a square length, like, does it really produce that much of a different shape? Hang on. Do it in squared space. No. That would be bad as well, wouldn't it? Yeah, you could probably monkey around with the scale at that point. But yeah, it would be too much, I think. But yeah, that I was trying to see if removing the length or the square root in there basically would help, but it's not too much. Cool. Right. I think that's in a good place. We just got to figure out like how could we possibly add. How does that compare to the brick? It's kind of similar, isn't it, in terms of complexity? There's a few signs there though. The distance function, the ray march. Yeah, the question is then how would you get, like you're doing an SDF to the sphere, right? So I reckon once you hit the sphere's surface, well, it's an ellipsoid in it, but you could probably do some hair-like structure maybe. You know, there is ways to like twist. There is ways to do the twisting and all that, but twisting is probably not what you want. But we could, so that's our rotations, right? We could add displacement to it. the displacement, they just use like a sine. Yeah, that's just a simple like noise basically, isn't it? So we could add noise, and you could probably get, if you do it at high frequency enough, you might be able to get it looking like hair maybe, but maybe not. Yes, things to think about and things to play around with. What is this smooth union doing? Oh yeah, it's not too bad, is it? It's quite a bit of maths, but if we just did a min, yeah, so that's about 5 milliseconds. 5.2, so it's not too bad. Cool. So yeah, it should be on tomorrow, hopefully, at 2 p.m. I might have to shuffle things around, though. I want to try and speak to my pastor tomorrow, but he's not messaged me back. So there's a Discord channel if you're going to come and chat in the meantimes. And if you want to get access to the code and run it on your local machine, you can support the channel via the Ko-Fi membership there and support the channel at the same time. Appreciate everyone who's supporting the channel. But yeah, so next stream will be hopefully tomorrow at 2 p.m. and then one on Sunday as well. So we'll just try and make this moss look a little bit more detailed now, and then see if we can, when we get the little bit of detail on there, maybe like the hair or something like that. I don't know, maybe we got to choose like a hair thickness or whatever about how deep it wants to go into this blob. And then we'll try and see how to layer it on top of a brick, right? So we'll just put the brick in here and do 2 materials, and yeah, obviously performance will be incredibly worse, but it'll be fine. It should look cool. Right. In the meantime, guys, have a good tomorrow, and hopefully, yeah, I'll see you tomorrow. Have a good night. Oh, frozen. I'm on computer. Here we go, right back. Bye bye. God bless you guys. Bye bye.